Hello everyone and welcome back to the channel. If you are designing a complex system today, chances you are using or thinking in terms of microservices. Small independent services that work together. But as you add more and more services, integrating with them from your client applications like a web or mobile can quickly become a chaotic maze. How do you manage dozens or hundreds of independent endpoints? This is precisely the problem solved by an API gateway. In system design interviews, discussing an API gateway demonstrates a clear understanding of modern distributed architecture. Today, we are diving into its crucial role. So, let's imagine you have a microservice architecture. You might have, let's have like, this is the client. We might have like a user service. We might have, let's call it with S here. We might have maybe, what else? User service, a product service. Might have an order service and so on, but let's just set order. Okay, and also you can have a payment service. So now think about a mobile app or maybe a client, maybe browser or something like that. And this browser will try to interact with all of these services that you can see here. It needs to know the specific endpoint for each service. You can see here. It needs to handle security like authentication, authorization logic for each service. It might need to make multiple calls to different services just to render a single screen. Like, for example, product details from one service, reviews from the other, things like that. Managing rate limiting as well and other cross-cutting concerns across all these services become a nightmare. This complexity on the client side, coupled with the management headache on the server side, highlights the need for central orchestrator, which is an API gateway. But what is an API gateway? So if we have our example here, so we have a client, let's take the red. We have the client. Let's say that we have our servers. So I have service 1, let's call it service 1, and let's call it S2 and S3. Okay. And between them, we will have API gateway. So an API gateway is a single unified entry point for the client request. So all the client requests will go through the API gateway. Okay. And this is in any microservices based application. You'll find an API gateway and it will be the unified entry for all client requests. It sits between the client and the applications, services, and yeah. And while it functions as a type of reverse proxy, I don't know if you know reverse proxy or not, but you can see the videos. I guess we have, you can find them in the networking playlist. So while it functions as a type of reverse proxy, it's more intelligent than that. Think of it as a smart service disk for your backend microservices. All client requests go through the gateway, which then intelligently will route them to the appropriate service. But it doesn't only distribute the request or direct the request to the appropriate service. It does a lot of things more than that, and we will discuss them right now. So API gateways take a wide array of responsibility, like centralizing concerns that would otherwise be duplicated across many microservices or handled inefficiently by clients. The first thing, single entry point. It provides a unified a single entry point for all your backend services, simplifying how client applications interact with your system. A client only needs to know the gateway's address, and that's it. Number two, routing and request aggregation. Let's talk about routing first. The gateway directs incoming requests to correct microservices based on the URL path, like headers or maybe some sort of criteria, like for example, API/users. So it will be directed to the user's servers. For example, API/products, it will be redirected to the product service. And two, we have aggregation. Aggregation, like for complex client screens, the gateway can fan out a single client request to multiple backend services or microservices, collect their response, and then aggregate them into a single simplified response for the client. This reduces the number of round trips the client needs to make. Number three, authentication and authorization. The API gateway is ideal place to centralize security enforcement. It can validate API keys, JSON Web Tokens, or OAuth tokens, protecting your backend microservices from unauthenticated or unauthorized access. The backend services then only receives authenticated requests. Number four, rate limiting and throttling. It protects your backend services from being overwhelmed by too many requests from individual clients. The gateway can enforce rate limiting, rejecting requests once thresholds is met. Next, we have SSL and TLS termination. So the gateway can handle the CPU-intensive encryption and decryption of HTTPS traffic, offloading this work from your backend microservices and allowing them to focus on business logic. Number six, response transformation. It can modify responses from backend microservices to suit the specific needs to different clients. For example, simplifying a complex JSON response for a mobile app with limited bandwidth. Next, we have logging and monitoring. Being the single entry point, the gateway is a natural place for centralized logging of all incoming requests and monitoring traffic patterns, providing valuable data for analytics, debugging, and security auditing. Number eight, protocol translations. An API gateway can expose a standard REST API to external clients while communicating with its backend microservices using different, more performant protocols like gRPC, which uses protocol buffer internally. And number nine, circuit breaking, like it can detect failing or slow backend services and apply circuit breakers, preventing requests from being sent to unhealthy services and stopping cascading failures throughout the microservices architecture. Okay. So what is the advantages of API gateways? I guess I said everything. So to just make it easier for us, the advantages, it just simplified client applications and development, centralized the crucial cross-cutting concerns like security, rate limiting, and logging. Also improves security by hiding the internal topology of your microservices. Also, it enables easier refactoring and evolution of backend microservices. Lastly, it facilitates faster overall development by decoupling client and service development. So what is the disadvantages? It's not all great though. First, we have a single point of failure and bottleneck. Like if not properly designed for high availability and scalability, and if you didn't add redundancy to your API gateway, the gateway itself can become a single point of failure or a performance bottleneck. Number two, I would say increased latency. Like every request now has additional hop through the gateway, adding a small amount of latency. Next, we have a development complexity because the gateway requires careful configurations, maintenance, and its own development cycle. And next, we have overall or over centralization. Like there are a risk of the API gateway becoming a monolithic gateway if too many responsibilities are dumped onto it. Yeah. Okay, so how to discuss API gateways in your system design interviews. So in an interview, when designing a microservices system, bring up the API gateway to solve specific problems like unifying client access, centralizing authentication, or handling request aggregation. Discuss its benefits, but critically also its drawbacks and how you would mitigate them. This demonstrates a well-rounded and strategic design approach. I would say that, and use them if you have to build a microservice architecture or a microservice system. If you think that the system that you are trying to design is not a microservice, it doesn't make any sense to use an API gateway. So yeah, that's it for this video, and see you in the future.